Hi guys, welcome back to part 2 of this video. We are on question 5. So let's crack on with it. A company is hosting a web application on AWS using a single Amazon EC2 instance that stores user uploaded documents in an Amazon EBS volume. For better scalability and availability, the company duplicated the architecture and created a second EC2 instance, an EBS volume in another availability zone, placing both behind an application load balancer. After completing this change, users reported that each time they refreshed the website, they could see one subset of their documents or the other, but never all of the documents at the same time. What should a solutions architect propose to ensure users see all of their documents at once? Good. So the options are A, copy the data so both EBS volumes contain all the documents. B, configure the application load balancer to direct a user to the server with the documents. C, copy the data from both EBS volumes to Amazon EFS. Modify the application to save new documents to Amazon EFS. And D, configure the application load balancer to send the request to both servers, then return each document from the correct server. Okay, so what do you think is the answer? Right? I'm going to give you a couple of seconds to choose the answer, but it looks like the answer is quite obvious. Yeah, so I believe it should be C. So let's see what the community says. Yeah, 100% for C. Copy the data from both EBS volumes to Amazon EFS. Modify the application to save new documents to Amazon EFS. Now, why is C the answer? So a bit of explanation is this. Now, to ensure users can see all their documents at once in the duplicated architecture with multiple EC2 instances and EBS volumes behind an application load balancer, the most appropriate solution is option C. So, in other words, option C meets the requirement. The requirements are spelled out in the question. Okay. So, in option C, what we do is that the solution architect is going to copy the data from both EBS volumes to Amazon EFS. Okay, that is the Elastic File System, and modify the application to save new documents to Amazon EFS. So in summary, with option C, it involves copying the data to Amazon EFS and modifying the application to use Amazon EFS for document storage. And this is the most appropriate solution to ensure users can see all their documents at once in the duplicated architecture. Amazon EFS provides scalability, availability, and shared access, allowing both EC2 instances to access and synchronize the documents seamlessly. That is why we will go for C. EFS reduces latency and all users can see all files at once. Okay, so Elastic File System is what is, going to meet the requirement, and therefore we will go for that as the answer. All right, let's look at question number 6. A company uses NFS, and NFS is a network file system. NFS, a network file system, something that was designed in 1984 by Sun Microsystems, blah, blah, blah. We are not going to go into the history of NFS, but it simply stands for network file system. So a company uses network file system, NFS, to store large video files in on-premises network attached storage. Each video file ranges in size from 1 megabyte to 500 gigabytes. The total storage is 70 terabytes and is no longer growing. The company decides to migrate the video files to Amazon S3. The company must migrate the video files as soon as possible while using the least possible network bandwidth. Very important. While using the least possible network bandwidth. What solution will meet these requirements? So A, create an S3 bucket. Create an IAM rule that has permissions to write to the S3 bucket. Use the AWS CLI to copy all files locally to the S3 bucket. B, create an AWS Snowball Edge job. Receive a Snowball Edge device on premises. Use the Snowball Edge client to transfer data to the device. Return the device so that AWS can import the data into Amazon S3. C, deploy an S3 file gateway on premises. Create a public service endpoint to connect to the S3 file gateway. Create an S3 bucket. Create a new NFS file share on the S3 file gateway. Point the new file share to the S3 bucket. Transfer the data from the existing NFS file share to the S3 file gateway. And D, set up an AWS Direct Connect connection between the on-premises network and AWS. Deploy an S3 file gateway on-premises. Create a public virtual interface, VIF, to connect to the S3 file gateway. Create an S3 bucket. Create a new NFS file share on the S3 file gateway. Point the new file share to the S3 bucket and transfer the data from the existing NFS file share to the S3 file gateway. D is really, loaded, but don't be fooled by it. It could just be a distraction. That's what they do with these exams. Now, if you look at it, one of the key requirements that the solution needs to meet is the company must migrate the video files as soon as possible using the least possible network bandwidth. In the video, the size of the video, it ranges from 1 megabytes to 500 gigabytes. So to use the least possible network bandwidth can be a challenge if you don't find the most befitting Amazon, AWS, tool or service. AWS is already service, Amazon Web Service. That's what AWS stands for. So if you say AWS service, it's like you've repeated a service, So you can just say, if you don't use the befitting AWS for this solution, and it's just right. Okay, right. So I see the answer to be between B and C. Okay, I see the answer to be between B and C. So for instance, if you look at B, if you're analyzing B as the answer, okay, you can say, on a Snowball Edge device, you can copy files with a speed of up to 100 gigabytes per second. So 70 terabytes will take around 5,600 seconds. So very quickly, less than 2 hours. Now, the downside is that it will take between 4 to 6 working days to receive the device, and then another 2 to 3 working days to send it back, and for AWS to move the data onto S3 once it reaches them. The total time is 6 to 9 working days. So bandwidth use is 0. Yeah, but even though the bandwidth use may be 0, we will not still want to wait for that long. Okay, so Snowball Edge would use 0 bandwidth. Okay, because you can just install the Snowball client or the AWS Ops Hub on the service and copy the files into the device. Then it's shipped back to AWS facility and placed into S3. The Snowball is like this big white thing where you can copy. So it doesn't use any network connectivity bandwidth. Okay, you just do that and you ship it to the AWS for them to send it to the S3. So it makes sense to choose B as the answer. But if you look at option C, the key words in the question is NFS, network file system, S3, and low bandwidth. Now, S3 file gateway retains access through NFS protocol so that existing users don't have to change anything while being able to use S3 to store the files. The question also gives a clue that we only need to upload existing 70 terabytes and no data is added. Okay, so the data have accumulated to 70 terabytes. So that is what we need to upload. And there's no data added to that 70 terabytes. So this gives a clue that users only need to read data via NFS and don't need to write to S3 bucket. So the existing data can be quickly uploaded via endpoint to S3 bucket by admin. And that will also give zero bandwidth. Okay. So it's a bit dicey, choosing between B and C. But because the question contains NFS, I'll probably go for C. Deploy an S3 file gateway on premises. Create a public service endpoint to connect to the S3 file gateway. Yeah, so you can do that, because S3 file gateway retains access through NFS protocol so that the existing users don't have to change anything, okay, while being able to use S3 to store the files. Okay, so that can be done. And B can also be done. But I will go for C. Yeah, so the community, most people, not surprised, voted for B. But, the answer is C. Deploy an S3 file gateway on premises. Yeah, it's a very tricky question. It's quite a tricky question, so not surprised that a lot of people will go for B. Because B also makes a lot of sense, to be honest. Yeah. Okay, so question number 7. A company has an application that ingests incoming messages. Dozens of other applications and microservices then quickly consume these messages. The number of messages varies drastically and sometimes increases suddenly to 100,000 each second. The company wants to decouple the solution and increase scalability. Which solution meets these requirements? Company has an application that ingests incoming messages. They ingest incoming messages. So dozens of other applications and microservices then quickly consume these messages. Dozens of other applications and microservices then quickly consume these messages. The number of messages varies drastically and sometimes increases suddenly to 100,000 each second. Okay. The company wants to decouple the solution and increase scalability. Which solution meets these requirements? So A, persist the messages to Amazon Kinesis Data Analytics, configure the consumer applications to read and process the messages. B, deploy the injection application on Amazon EC2 instances in an auto-scaling group to scale the number of EC2 instances based on CPU metrics. C, write the messages to Amazon Kinesis data streams with a single shard. Use an AWS Lambda function to pre-process messages and store them in Amazon DynamoDB. Configure the consumer applications to read from DynamoDB to process the messages. And D, publish the messages to an Amazon Simple Notification Service. That is Amazon SNS, Simple Notification Service, SNS. So publish the messages to an Amazon SNS topic with multiple Amazon SQS, that is Simple Queue Service subscriptions. Then configure the consumer applications to process the messages from the queues. Okay. This is, I believe, the answer. I'll leave you a bit to think of the answer. Okay, so honestly, I don't know. It looks like it's going to be either A or D, but A makes I mean D, yeah, A or D, but D makes more sense to me than A. So I'll probably go for D. Okay, so not 79% of people voted for D, but they say the answer is A. Interesting. Interesting. Okay. Now, why did I choose D? I agree with most of the things that the community people said. So, um, A is suitable for real-time analytics and processing of streaming data rather than decoupling and scaling message injection and consumption. Yeah, so if you're talking about real-time analytics and processing of streaming data, then of course it's going to be A. But here, the requirement is decoupling and scaling message injection. You know, so I chose D because it is the recommended solution for decoupling and scalability. Okay, because the injection application can publish messages to an Amazon simple notification service SMS topic, and multiple consumer apps can subscribe to the relevant SQS Amazon Simple Queue service. So SNS ensures that each message is delivered to all subscribed queues, allowing the consuming apps to independently process the messages at their own pace and scale horizontally as needed. Now, this provides loose coupling, scalability, and fault tolerance as the queues can handle message spikes and manage the consumption rate based on the consumer's processing capabilities. Yeah, so it kind of makes sense to choose D. You know, another thought I've seen here is that, by default, an SQS queue can handle a maximum of 3,000 messages per second. However, you can request higher throughput by contacting AWS support. AWS can increase the message throughput for your queue beyond the default limits in increments of 300 messages per second up to a maximum of 10,000 messages per second. Now, it is important to note, though, that the maximum number of messages per second that a queue can handle is not the same as the maximum number of requests per second that SQS API can handle. The SQS API is designed to handle a high volume of requests per second, so it can be used to send messages to your queue at a rate that exceeds the maximum message throughput of the queue. Yeah, but you know, they believe the answer is A, and reason that's I gathered from the community is that, for example, Kinesis data analytics integrates with Amazon Kinesis data streams and Amazon Kinesis data fire hoods, so you can readily ingest streaming data. So you just point Kinesis data analytics at the input stream, and it will automatically read the data, parse it, and make it available for processing. So you can emit processed results to other AWS services. Other AWS, you shouldn't add services to it. AWS is um, Amazon Web Service. So people normally say AWS services, but it's wrong. So you can emit process results to other AWS, including Amazon S3, Amazon Redshift, and Amazon OpenSearch Service through Kinesis data firehose. Then you can also send output data to Amazon Kinesis data streams to build advanced stream processing pipelines. So, um, yeah, maybe we'll go with A, but D is also very, very convincing. It's compelling. Right. Question number 8. A company is migrating a distributed application to AWS. The application serves variable workloads. The legacy platform consists of a primary server that coordinates jobs across multiple compute nodes. The company wants to modernize the application with a solution that maximizes resiliency and scalability. How should a solutions architect design the architecture to meet these requirements? They want to modernize the application with a solution that maximizes resiliency and scalability. Okay, so these are the options. A, configure an Amazon SQS queue as a destination for the jobs. Implement the compute nodes with Amazon EC2 instances that are managed in an auto-scaling group. Configure EC2 auto-scaling to used scaling. B, configure an Amazon simple queue service queue as a destination for the jobs. Implement the compute nodes with Amazon EC2 instances that are managed in an auto-scaling group. Configure EC2 auto-scaling based on the size of the queue. C, implement the primary server and the compute nodes with Amazon EC2 instances that are managed in an auto-scaling group. Configure AWS Cloud Trail as a destination for the jobs. Configure EC2 auto-scaling based on the load on the primary server. And D, implement the primary server and the compute nodes with Amazon EC2 instances that are managed in an auto-scaling group. Then configure Amazon EventBridge, that is Amazon CloudWatch events, as a destination for the jobs. Configure EC2 auto-scaling based on the load on the compute nodes. Right. So I think the answer is either B or C. Yeah, I think the answer is either B or C. Because when it comes to auto-scaling, you can configure Amazon simple queue service as a destination for the jobs to handle the auto-scaling. So once you do that, you implement the compute nodes with Amazon EC2 instances that are managed in an auto-scaling group. But if you look at C also says implement the primary server and the compute nodes with Amazon EC2 instances that are managed in an auto-scaling group. Then configure AWS Cloud Trail as a destination for the jobs. Then you configure EC2 auto-scaling based on the load on the primary server. Okay. So in the question, there was a mention of the legacy platform consists of a primary server that coordinates jobs across multiple compute nodes. Okay, so if you look at C, it kind of take care of what the server also needs to do. So it says implement the primary server and the compute nodes with Amazon EC2 instances that are managed in an auto-scaling group. So in all of this, if you look at B and C, they are all doing their best to ensure that the scheduled auto-scaling is done. But C is also making sure that this is done on the primary server. Okay, there's a special mention of the primary server, which is a requirement in the job. Okay, so that is why even though B makes sense, you cannot look down on C. So for B, if you configure an Amazon SQS queue as a destination for the jobs, and you implement compute nodes with EC2 instances, managing an auto-scaling group, and configure EC2 auto-scaling based on the size of the queue, it can seem as the most suitable solution, because with this approach, the primary server can queue jobs into the SQL queue, and the compute nodes can dynamically scale based on the size of the queue. This ensures that the compute capacity adjusts accordingly to the workload, maximizing resiliency and scalability. And the SQL queue acts as a buffer decoupling the primary server from the compute nodes and providing fault tolerance in case of failures or spikes in the workload. So in B also makes sense. Okay. So, but if you look at C, you can't take away the fact that it could also be C. Okay. But, the cloud trail, the mention of the cloud trail in C is what I'm struggling with, because the use of cloud trail is for AWS events. It doesn't really, it's not really meant for jobs, receiving jobs. So I will probably go for B. So the most voted is B, but it says the correct answer is C. And maybe in the comment section, you can probably explain why, if you understand why they are saying C is the answer. I'm not saying that C cannot be the answer, but B seems to meet the requirements more than C for me. And even though it talks about the primary server, if you choose B, okay, you can configure Amazon Simple Queue service on a primary server. Okay, that it can be the destination for those jobs. Okay, so yeah, if you think C is the answer, please explain in the comments why you think it's. And remember, we are all trying to study together. Even if I don't meet that question, it's not only for the exams. To be honest, this is for life. If you want to be an AWS solution architect, yes, your first focus should be passing the exams and getting the certification, so that it will serve as a validation to the market that you've got the skills. But you can get the certificate, but if you don't really understand these concepts well, you will not be a good solution architect to a company. So yes, let's leave some comments in the session so that we all study together. Okay, brilliant. Okay, so we'll move to the next question. Right. Question 9. A company is running an SMB file server. SMB stands for server message block. Server message block. And, it's a protocol. SMB is a protocol. And basically, it's a client-server communication protocol that is used for sharing access to files, printers, serial ports, and other resources on a network. Okay, yeah, so that is SMB. So a company is running an SMB file server in its data center. The file server stores large files that are accessed frequently for the first few days after the files are created. After 7 days, the files are rarely accessed. Now, the total data size is increasing and is close to the company's total storage capacity. A solutions architect must increase the company's available storage space without losing low latency access to the most recently accessed files. The solutions architect must also provide file life cycle management to avoid future storage issues. Which solution will meet these requirements? A. Use AWS Data Sync to copy data that is older than 7 days from the SMB file server to AWS. B. Create an Amazon S3 file gateway to extend the company's storage space. Create an S3 lifecycle policy to transition the data to S3 Glacier Deep Archive after 7 days. C. Create an Amazon FSx for Windows file server file system to extend the company's storage space. And D. Install a utility on each user's computer to access Amazon S3. Then create an S3 lifecycle policy to transition the data to S3 Glacier Flexible Retrieval after 7 days. Good. So what will be the solution that will meet these requirements? What are the requirements? The fact that the company is running an SMB file server in its data center. So any solution that you propose should bear this in mind. And the fact that the file server stores large files that are accessed frequently for the first few days after the files are created. And the fact that after 7 days, the files are rarely accessed. Then the total size is increasing and it's close to the company's total storage capacity. And the fact that a solutions architect must increase the company's available storage space without losing low latency access to the most recently accessed files. And the fact that the solution architect must also provide provide file lifecycle management to avoid future storage issues. So a lot of requirements to meet here. Which will be the best solution to meet this requirement? Right. So I believe A and D can be taken out because if you are talking about the fact that total size is increasing and all of that, then I don't think these two, A and D, will be good. But B and C are kind of competing for the answers because if you look at B, for instance, it says create an Amazon S3 file gateway to extend the company storage space, which is going to meet the requirement because the total data size is increasing, it's close to the company's total storage capacity. And the next is create an S3 lifecycle policy to transition the data to S3 Glacier Deep Archive after 7 days. Because after 7 days, the files are rarely accessed. So if you create that lifecycle policy for the S3 and it's transitioned to Glacier Deep Archive, then it's good. So you can see that B very much meets the requirement. But as to whether it's not going to affect the low latency access to the most recently accessed files is also another issue. If you look at C, did I say D is not good? Oh, I didn't read D well. It's rather A and C because C does Amazon FSX for Windows. No. We are not talking about file system here. If you look at D, this says install utility on each user's computer to access Amazon S3, create an S3 lifecycle policy to transition the data to. So both of them believe that a lifecycle policy needs to be created to transition the data from S3 to S3 Glacier Flexible Retrieval. Okay, so sorry, the D says flexible Glacier Flexible Retrieval, and B is Glacier Deep Archive. That is interesting. Now, I think the answer will lie between S3 Glacier Deep Archive and S3 Glacier Deep Retrieval. If we were able to, know the difference between or what each of them does, then it will be easy to know the answer. So I'm just going to remind myself from GPT the difference between the two. So I'm asking ChatGPT. So we've got S3 Deep Glacier Archive. So I'm going to prompt ChatGPT. So what is the difference What is the difference? You might not see it on the screen, but you can, maybe you also see it. I don't know. I don't know even which screen I'm sharing. So what is the difference between, what is the difference in function? What is the difference in function between S3 Glacier Deep Archive and S3 Glacier S3 Glacier Flexible Retrieval? Because I believe that will be where the answer lies. So, yeah, of course, it starts by saying, as of my last update in September 2021. This guy loves saying that. Okay, so let's go to the meat of it. It says S3 Glacier Deep Archive. S3 Glacier Deep Archive is designed for long-term archival of data that is accessed rarely, typically only once or twice a year. It's the lowest cost storage class among Amazon S3 options. So it offers low cost and the retrieval time can take hours, making it suitable for scenarios where the data access latency is not a concern. And durability and availability. Data in S3 Glacier is stored across multiple devices and facilities, providing high durability and availability. Okay. But when you are retrieving it, it takes long. So if access latency is not a concern, then Glacier Deep Archive is what you would want to go for. Okay. But if you look at the question, it says we want a storage space without losing low latency access. Okay. And here it says that without losing low latency access. So we don't want latency access to be high, in other words. But here it says you have to use Glacier Deep Archive if, data access latency is not a concern. But if you look at the requirement, it's a concern for them. They don't want to lose that. Okay. Now let's look at S3 Glacier Flexible Retriever. It says S3 Glacier Flexible Retriever is not a distinct storage class, but rather a feature that allows you to configure the retrieval speed and cost based on your specific requirements within the S3 Glacier storage class. With this feature, you can select between 3 retrieval options: expedited retrieval, standard retrieval, and bulk retrieval. Okay, so the Glacier Flexible Retriever is saying it's not a distinct storage class. But it gives you the option to choose expedited retrieval, standard retrieval, or bulk retrieval. So expedited retrieval, this option allows you to retrieve data from S3 Glacier within 1 to 5 minutes, then standard within 3 to 5 hours, and bulk retrieval can take 5 to 12 hours. Okay. And the purpose is that it's designed for, the S3 Glacier Archive, designed for long-term archival at a very low cost. Okay. But the retrieval latency is high. Okay. So because losing low latency access is something that is of a concern to them, then it makes sense that the answer is D. Okay, because if you go for deep archive, it means that losing your low latency is not a big deal. Okay, so the answer I believe should be D. So most people voted for B, but from the analysis I've done, it looks like it seems that the answer D is correct. Perfect. Okay. Oh, this video has been quite a long video, but it's been worth it. So I will see you in part 3, the next video. Thanks for hanging out with me.